Hey, I'm Srijan Sai Udala, and this is my take-home final test. Now, what I did is bias detection and model explainability on a synthetic hiring data set. So the goal is building a hiring classifier, inspect sharp explanations, measure fairness metrics, and apply mitigation strategies to reduce unwanted bias. This notebook provides an end-to-end workflow for detecting, understanding, and mitigating bias in machine learning models. Use a synthetic hiring data set so we can precisely control how much bias is present and clearly demonstrate how fairness tools and sharp explanations respond. By the end of this notebook, you will learn to generate datasets with configurable bias towards or against protected groups, analyze model behavior using SHARP, compute key fairness metrics such as demographic parity and equal opportunity, compare feature attribution between demographic groups, apply bias mitigation techniques, and evaluate their effectiveness. So the core concept of this lesson is detecting, explaining, and mitigating bias in machine learning. We do this using three components: synthetic bias data, sharp explainability, fairness metrics, plus thresholding. So when you ask me why does this matter, models trained on biased data may discriminate even when accuracy looks high. This is especially important in real systems like hiring algorithms, financial approvals, and college admissions. Our synthetic hiring scenario shows exactly how bias is introduced, how it affects model predictions, and how we can measure and reduce it. So, common student misconceptions are students often believe high accuracy means the model is fair, sharp values reflect causality, threshold should stay fixed at 0.5 for all groups. So, first, we install all the packages. This is data generation, synthetic hiring data set. We generate all the data and we do quick EDA. Before building models, we basically examine the data set to understand group level patterns. This overall higher rate by gender, higher rate by race. So you can see the output here. The overall higher rate is 0.375. This is by gender and by race. We have a bar chart to show it visually. Feature preparation in this stage, we create the feature matrix used for modeling and preserve protected attributes for fairness evaluation. Selecting numeric predictor variables, one hot encoding demographic categories so the model can use them. Keeping raw gender race labels separately for fairness and sharp grouping. Splitting the data into training and testing sets with stratification. So we use XGBoost. Use XGBoost for its strong performance on tabular data and compatibility with Sharply Explainer. In this section, we train a baseline classifier and evaluate performance accuracy. After training, we'll inspect global and local explanations using Sharp. So global explanation with Sharp, use a sample of test data to compute Sharp values and visualize in absolute feature importance, how each feature pushes predictions toward or away from positive hiring decision. The demographic feature plays an outsized role in the model decisions. As you can see, this is the impact. So local explanation example. Why did the model predict this specific applicant should or should not be hired? By selecting a single instance, we can visualize the model's baseline prediction, feature contributors pushing the prediction up or down. Their demographic attributes influence this particular decision. So you can see everything: years of experience, skill score, race, interview score, gender, female, male, race can be Hispanic, white, black, fairness metrics, demographic parity difference, disparate impact ratio, equal opportunity difference. We compare sharp attributions by group. We compare it. This is what we get between male and female. This is mitigation one, reweighing. This is mitigation two, thresholding. That was pre-processing, and this is post-processing. So, discussion and takeaways. Sharp helps reveal which features drive model decisions. Fairness metrics show group level disparities consistent with the synthetic penalty. Mitigation strategies reduce disparity, discuss trade-offs, accuracy versus fairness, e-group threshold fairness versus individual fairness. Weighing may hide structural bias in the data. So this is a workflow diagram. This is what we're doing in this notebook. So stronger injected bias. Now we run a second scenario where the penalties for certain protected groups are stronger. So this helps students observe how sharp and fairness metrics respond as bias severity increases. As you can see, these are all the same attributes. So we compare scenario A with scenario B. The output here with regards to scenario and scenario B. So these are the exercises: increase bias magnitude, feature ablation, model comparison. And these are some of the debugging tips and common pitfalls. And yes, this is interactive widget explore threshold per group. Now let me go into the Streamlit app. This has very basic and simple UI. Anybody can understand it and use it. So this is the size of the data set that we can adjust. This is the seeding. This is a female threshold and a male threshold. Used separate thresholds for both. So basically, this is the sample data of gender, race, experience, education, skill score, interview score, penalty hire, and everything. So baseline male positive rate, then adjusted DPD. You can see the difference between female and male. Here we have all the options: download plot as PNG, zoom, zoom in. So this is interactive probability distribution by gender. This is the predicted probability distribution. This positive rate versus threshold. All of these are interactive. Yeah, this is model ROC curve. Then this is the confusion matrix at current thresholds. How you can actually do this. You can see the actual everything changes. Actual values change. When you change it, when you let's say we change the male threshold, as you can see, everything that we change here is reflected here, and it's all visualized, completely visualized. Then obviously the table and everything also changes. We adjusted it and then look at the differences in the values. So as we adjust it, it keeps changing. And it's even shown visually, which is actually really good because it's easier when it is shown visually through graphs and charts. So this is my complete UI and this is my complete app for Thresholding Explorer. Thank you. This was it. Thanks for listening.